So we need to simplify the given expression, and we'll also use it to obtain the value of the following. So let's begin. So here our task will be to convert square root of 3 plus I to its polar form, as well as square root of 3 minus I to its polar form. So let's begin by supposing that we have the complex number z1, and that's represented by square root of 3 plus iota. Now r will be given by, so underneath the square root we will take the real part, then square it and add it to the imaginary part and square it. So this is going to give us a value 2. So that means our value is 2. An argument of our complex number z1, so that will be equals to the inverse tangent or the arc tangent of the imaginary part, which is 1 divided by the real part, which is square root of 3. Now we know that tangent inverse 1 over square root of 3, so that's actually tangent of pi over 6. So that means tangent inverse of tangent of pi over 6 is going to give us the value pi over 6, and we can express our complex number z1 in the polar form as 2 multiplied to cosine of pi over 6 plus iota times sine of pi over 6. So let's label this as equation number 1. Now we will move on to our second complex number z2, which we represented as square root of 3 minus iota. So here the r value is also going to be equals to 2. Now we'll try to find out the argument of our complex number z2, which is given by the inverse tangent of the imaginary part, which is -1 divided by the real part, that's square root of 3. So that will be equals to tangent inverse of negative of tangent of pi over 6. Now we know that our tangent is an odd function, meaning tangent of negative theta, that's equals to negative tangent of theta, which means we can absorb this negative sign to get tangent inverse of tangent of negative pi over 6, which gives us a value negative pi over 6. So we have obtained the argument of our complex number square root of 3 minus I, which is negative pi over 6, and we can express it in the polar form as 2 multiplied to cosine of negative pi over 6 plus iota times sine of negative pi over 6. Now cosine is an even function. That being an even function would simply mean that cosine of negative theta is positive cosine theta, but sine is an odd function. That means sine of negative theta will be negative sine theta. So since we have our argument as negative pi over 6, this is going to give us a value 2 times. We'll have positive cosine of pi over 6, and sine of negative pi over 6 is going to give us negative iota of sine pi over 6. So this is the value of our complex number z2. So our next task will be, so let's label this as equation number 2. Now we'll take our complex number z1 and raise it to the power of n, which means we have 2 raised to the power of n multiplied to cosine of pi over 6 plus iota times sine of pi over 6 whole raised to the power of n. So this is going to give us the value 2 raised to the power of n. Now here we are going to use the de Moivre's theorem. So de Moivre's theorem states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of n, so this will be equals to cosine of n theta plus iota times sine of n theta. Right. So we will now have cosine of n pi over 6 added to iota times sine of n pi over 6. So we'll label this as number 3. Now we are going to raise our complex number z2 to the power of n, which will give us 2 raised to the power of n. So we can apply the de Moivre's theorem, and this is going to give us cosine of n pi 6 minus iota times sine of n pi over 6. Let's label this as equation number 4. Now we will be adding 3 with 4, and this is going to give us z1 raised to the power of n added to z2 raised to the power of n. So we can take 2 raised to the power of n as the common factor, and when we add 3 and 4, the imaginary part will get cancelled off because they are additive inverses of each other. So this will be simply 2 times cosine of n pi over 6. Now replacing the value of z1 with square root of 3 plus iota whole raised to the power of n, and we are replacing the value of z2 with square root of 3 minus iota whole raised to the power of n. So this is going to give us 2 raised to the power of n plus 1 times cosine of n pi over 6. So this is the simplified form of a given expression. Next, what we'll do, we'll try to find out the value by letting n equals to 14. This means we have square root of 3 plus iota raised to the power of 14 plus square root of 3 minus iota raised to the power of 14. So this is going to give us 2 raised to the power of 14 plus 1. So we'll have 15 multiplied to cosine of 14 pi over 6. So we will have 2 raised to the power of 15 multiplied to cosine of, so 14 pi over 6 means we have 7 pi over 3. Now cosine of 7 pi over 3 can be also expressed as cosine of 2 pi plus pi over 3, which gives us 2 raised to the power of 15. Now cosine of 2 pi plus pi over 3 is simply cosine of pi over 3, and 2 pi plus pi over 3 means we are in the first quadrant where all trigonometric functions are positive, so cosine is also going to be positive. And we noted cosine of pi over 3, so that's 1 over 2. So our final value is going to be equals to 2 raised to the power of 14. So that means our simplified value of this particular expression is 2 raised to the power of n plus 1 times cosine of n pi over 6. And whenever we have n value equals to 14, our final value is going to be equals to 2 raised to the power of 14.